lately. But first, so I'm going to talk a little bit about the concept of land health and drylands and rangelands. Drylands is a classification of global ecosystems that's a little more narrow than rangelands, because there are areas that are quite humid that have rangelands in them, but I think they both sort of suffer from some of the same kinds of problems. And so that will be the bulk of my talk, but I did want to introduce you a little bit to the Jornada Experimental Range in case you're not very familiar with our program. We are based at Wooten Hall, just down to the west a little bit from here. We are a lab of the USDA Agricultural Research Service, which is the research arm of the USDA. We also manage the 300 square mile Jornada Experimental Range, which is right next door to the Drylands Desert Rangeland Research Center, which is another 100 square miles. And we kind of operate that from a research standpoint pretty contiguously. We coordinate a lot with NMSU and the College Ranch, which we call this Drylands Desert Rangeland Research Center. And so we have 400 square miles in which to do research, which is a monumentally large research area that we're fortunate to be able to work in, and for many other researchers to work in. We have about 500
recording in progress.
We have about 540 documented studies and about 130 active studies being carried out right now. The Jornada at Wooten Hall, we have 70 USDA and NMSU staff that are kind of split right down the middle, and this is our group of lead scientists. We have about 12 scientists, and you can just sort of see all the different disciplines associated with our program, ranging from animal science to ecology to data science. And so for those of you looking for jobs, perhaps sometime in the future, look up ARS and Jornada in particular. And let's get a slide. Okay. Yeah, so this is our programs. We have 5 core areas that we work in. Long-term ecological research through the NSF-funded LTER program here at NMSU since 1982. And we collaborate with a number of researchers at NMSU as well as other universities in that program. We also host a National Ecological Observatory site, also funded by NSF at the Jornada. This is a sort of standardized set of measurements of ecosystem processes that are collected at, I think, over 60 sites across the United States. We are a member of the Long-Term Agroecosystem Research Network, which is really focused on sustainable agricultural strategies in different regions. Land health knowledge systems, so this is monitoring and interpretation of land health, which I'll talk about in great detail. And we also host the Southwest Climate Hub, which provides synthesis and outreach and co-production on climate mitigation and adaptation in the Southwest. And we also partner very closely with the Sombro Institute for Science Education in really translating all of this research into K-12 as well as adult education programs in the community. And so we're very fortunate to have these programs together, and we're the only site in the United States that has all of these NSF and USDA funded programs. So our geographic scope is drylands and rangelands across the world. And so about 54% of the Earth's land area is designated as rangeland, and about 41% is dry enough from the point of view of the aridity index to be considered to be a dry land. And our primary goal that we share with all of our partners, including federal land management agencies as well as other research partners, is promoting land health. Land health is a term that makes a lot of folks, including me, uncomfortable sometimes because of the analogies that one wants to draw to human health. but it's a very important concept that we have to work with in terms of deciding whether or not we're doing good when we're making land management decisions, and how you define what good is. The original, and I think a still very salient definition, was from Aldo Leopold in 1944. In an essay he wrote, "The capacity for self-renewal in the soil, water, plants, and animals that together make up land." A modern definition of land health is the capacity of land relative to its potential. And I put that in italics because that's a really important concept that, as I will show, gets missed a lot in deciding what land health is, relative to its potential to sustain the delivery of ecosystem services. And so that's sort of the modern way now that we talk about what our goals are, the multiple ecosystem services that are provided by land. And a still more kind of modern take on land health is the mouthful of social ecological resilience. And you can sort of see why it's easier to say land health than social ecological resilience, but the capacity to withstand perturbation such that the system maintains its structures and functions. And so this is sort of acknowledging, all three of these definitions have a role, and this latter one is acknowledging that we're living in a very dynamic environment, and in many cases a transforming global environment. And so our approach, I like to call land management science. And so this is a science where kind of had this ordered from 3 to 1. Our end goal is to conserve land health and managed ecosystems with respect to soil health, biodiversity, ecological processes. In order to do that, we need to provide knowledge to assist land managers and policymakers in making decisions that conserve land health. And in order to do that, we have to define land health as well as land degradation. And you can see some common syndromes of land degradation here on the right: soil loss, salinization, shrub encroachment and annualization, thicketization in more mesic, woody environments that tend to cause fire, as well as soil fertility loss. And so the goal here is to provide a scientific basis for what Leopold called reading the land. There are really important implications to defining what land health is. Tens of thousands of private and government land managers just in the United States alone are making daily decisions based on land health concepts and their mental models, sometimes institutional models, sometimes scientific models, but more often than not, mental models that we carry around in our heads about how to achieve land health. And I was just in a conversation with a group of land managers at BLM today, talking about this very problem. We also have billions of dollars in government spending to conserve or restore land areas, such as through the 30 by 30 initiative. And then most recently, the monumental amount of money that was in the Inflation Reduction Act for conservation programs, billions of dollars, all told. So the stakes are high, and there are many ways in which the land health concept can go wrong. And so I'm going to go through a few slides now talking about the ways that they can go wrong before I briefly offer whatever solutions we have to offer that we're working. And the first of these is misidentify land potential. So this is when we incorrectly assert the characteristics of a healthy system or a degraded system to a particular land area. Degradation really can only be understood with respect to its geophysical setting. What in that second definition was land potential relative to its potential. All of these images, these are all pinyon juniper type systems, have been referred to by folks as degraded or encroached systems, where we're dealing oftentimes with the presumption that most of the ecosystems that we have, especially in this region, were grass dominated at one point, and that woody plant encroachment through disruption to fire cycles and overgrazing that reduced fuel loads was responsible for the woody states that we see today. But this is only true in a couple of instances, and most folks don't really know what those instances are, what distinguishes the cases where woody systems are naturally long-term woody plant-dominated systems versus recently encroached woody plant-dominated systems. On the left there, we have a woodland that is a historical woodland on fissured bedrock. So you see the fissured bedrock, those trees, even if they're skinny, they could be over 300 years old. And we've got accelerated mass spectrometer dates to show that. And this, of course, was believed to be a degraded savanna and was managed as such and cleared the trees. But this was an old growth woodland. In the bottom there, we have a historical savanna on fine textured soils. The trees are still greater than 150 years old, so they still predate grazing. But this is believed to be a tree encroached grassland. Wrong. On the right, however, we have, I'm going to try to move that little thingy right there. We have tree encroachment into a grassland on sandy soil due to loss of fire, disturbance, with continuous grazing. This is actually an encroached savanna. Probably could be a place where you might want to remove those trees. And then we have tree encroachment here in a meadow, and this is, of course, ponderosa forest, due to channelization and deepening of the water table. So this is another example of encroachment. But the geophysical setting can tell you a lot about what an encroachment is and what it isn't, what's a naturally woody dominated system. So a misunderstanding of land potential in turn can create flawed restoration prescriptions. You can go about planting trees in the name of climate mitigation, in the name of restoration in places where there were never trees. And in fact, this is happening as of, I think it was a day before yesterday in Mongolia, the Mongolian president, and we do a lot of work in Mongolia, as well as Argentina, and they were planting trees in steppe, not in the areas where there were trees, up in the hills, but in steppe as a restoration measure. And those trees are probably going to have to be irrigated or they will die. We can also remove trees and shrubs that were always there or were there for hundreds of years. Climate change is kind of adding a wrinkle to our concept of what potential is. And it's changing not only potential, but also the restoration trajectories over time. And so this is something that I worry about a little bit with some of the restoration that is happening in creosote bush shrublands being managed by various agencies, that we might find that initially, under our current climate right now, shrub removal might be successful in recovering grasses that were there historically. So this might be true restoration from the standpoint of an area that was encroached by creosote bush. It's on soil that we know was grassland at one time. We have lots of evidence on the Jornada for where shrub encroachment occurred. And it may indeed, right now, lead to grass restoration. But I wonder what's going to happen to those systems 20 years from now or 30 years from now. They become very hot, very erratic rainfall. Will sort of the benefits that we saw now, will they disappear in this new climate? And we will wish, if we had this to choose from, we will wish maybe we had kept those shrubs. Something to think about. Defining land degradation also historically has imparted political power. And so this is something else to think about, are the motivations behind how we talk about land degradation. This is a historical example detailed in a great book by Diana Davis. If you don't know Diana Davis, she has a couple of great books. She's a professor at UC Davis. This one, The Resurrecting the Granary of Rome, an environmental history of French colonial expansion in North Africa. She details how the colonial French designated what were naturally treeless areas as degraded forests in order for them to essentially expropriate those lands from Arab herders and Arab pastoralist communities. With quotes such as this one, the Arabs have been fatal. It is their sheep, their camels, and their goats that have ruined North Africa, when in fact they had been coexisting with those grassland systems for thousands of years. And a more modern take on this same kind of idea is asserting land degradation in order to create a problem to be solved. This is an example from a talk that was a very famous talk by Alan Savory, who was a proponent of holistic planned grazing. It has a number of other names to it, but basically what he did in this very well-regarded TED Talk that has now been viewed, and I checked again day before yesterday, 8.5 million people have seen this talk. And he says in this talk with this slide and those circles, generally what you see in green is not desertifying, and what you see in brown is, and these are by far the greatest areas of work. So everything that you see in brown, everything, all dry lands are desertifying. And that, of course, is not true. So the second way in which land health concepts can go wrong is in pushing narrow perspectives on the characteristics of land health. And so we might assert that a site is degraded based upon one indicator, or maybe just sort of a gut sense of it being degraded in the absence of a really rigorous multi-factor, multi-indicator evaluation of that system. And so this is a little stroll down memory lane for me. I started my career in graduate school as a master's student in northern Argentina in Salta province. That's what I looked like on the very far left there. Much fitter in those days, 30 years ago. And this is sort of what the environment looked like. That's a Puesto family in northern Argentina. They ran goats as well as cattle in this environment. There was amazing biodiversity, and this is sort of a little bit further away from the Puesto that had, it was kind of like mostly bare near the Puesto because the goats really inhibited even the woody plant regeneration, and further away you had a little bit more thicketization, but also a lot of bare ground. And so I was part of a project. It was a really great opportunity for a young graduate student to look at a gradient from degraded to what was called restored, where it was overgrazing, loss of valuable tree species, and bare compacted soil that was near the Puesto. And then further away, there was a project where there was fencing and silvopastoral techniques where they were doing a little bit of grazing and woody plant harvest. But it was essentially rotational grazing to try to restore open forest type setting. And so we said, okay, that's degraded right near the Puesto. And then further away, that was going to be the restored area. We did this as a design feature. We didn't ask whether it was restored, or we just said, right, that's what it was. And of course, we intended to go in and show how wonderful this restored area was relative to the grazing area. We already had in our minds what the result was going to be. It was just about going out and measuring the indicators to prove it. And in fact, what we found was that those open bare patches that were near the Puesto contributed to landscape level biodiversity. There was like a very little change in richness, but a very big difference in the composition of species, so that together we had what we call gamma diversity of a number of different animal groups was higher because of these two components in the landscape. You can see some of the species in the degraded side and some of the species in the restored side. Now, there were rare species in the restored area that were not present in the other area, which is really important to recognize. But none of these are particularly weedy species. These are all important components of the Argentine fauna. We also see a very similar kind of story in the United States in shortgrass steppe. This is a part of a study taking place in the shortgrass steppe, in which they've shown that bare ground areas that are caused either by very, very heavy grazing, by bison, or by prairie dogs that are eroding soil, that we would use rangeland health indicators based upon plants and soil to say is degraded, are actually necessary parts of the landscape for maintaining certain bird species in the landscape. This is a very common type of pattern that we've seen repeated across multiple studies. Another thing we have to take into account is that we may go in with a knowledge of processes that we import from other places and maybe apply them where they don't quite belong, because we don't really understand the local setting so much. I learned this from that gentleman, right, kind of a little bit further away from the horse is a soil scientist named Avadorj in Mongolia. And we had a big argument. He speaks decent English about this particular cut. I said, boy, that's got to be related to overgrazing on the side slopes of a hill that was then leading to lots of high intensity runoff that then blew out this meadow. And he convinced me over time, and especially after we saw some of the satellite imagery, that this is the dynamics of the system. This is just how it is. And there's a great paper where social scientists kind of worked with a group of herders and incorporated their concepts of what health was and what degradation was into an indicator system that now the herders are able to use. But the lesson there is it's probably good to talk to people locally before you make judgments about what degraded is. And now we're sort of in a situation where we're beginning to have to consider other kinds of indicators and maybe calibrate a little bit how we think about what indicators are going to be most important for us to pay attention to as we head into this era of thinking about climate mitigation as being a pretty important role for rangelands. I think about this quite a bit. We have a lot of folks that are asking us about applying biochar and compost to rangelands. There's a lot of work in California on this. I think that's probably from California, and it may or may not lead to increases in soil carbon in different settings, but it may also lead to nutrient runoff, lead in the soil, as well as invasions of exotic species, because you're changing, right? You're changing the biogeochemistry of the soils quite a bit. There may be a lot of other effects at play, and so one of the things that we talk about quite a bit is, okay, California, a lot of the grasslands, they're sort of pastures. They're just very heavily, intensively managed lands. And thinking about, blowing a lot of compost into our rangeland on the Jornada in a black gramma grassland, I just don't know that that's the same kind of system. Do we want that level of intensification in managing a system like the extensive grasslands in the Southwest? Anyway, there's going to be people that are going to be debating that for some time to come. The other thing that we think about with respect to climate mitigation is what the reference states, the healthy states versus the degraded states, how they're functioning relative to carbon uptake. And these are some unpublished data as yet to be revised that is part of the LTER program at the Jornada being run by Dr. Craig Tweedy and Dr. Marguerite Maritz-Tozier at the University of Texas, El Paso. They have what's called an eddy covariance tower, and it essentially measures the carbon balance above an ecosystem. So there's usually a footprint, and it's looking at respiration, right? What's being released as well as what's being taken up in those areas. And it creates a balance. It's called the net ecosystem exchange. And what you see here is when it's negative on this particular depiction, that means that's carbon uptake. This is a creosote bush shrubland, right? This is a type of ecosystem that we often call degraded, and the numbers are consistently negative. That means there's consistent carbon uptake over the years. It fluctuates, but we're getting somewhere up to 190, 180 in the last record we have. 180 grams of carbon per meter squared. Those are monstrous numbers relative to any kind of grassland ecosystem in the Southwest. Do we want to mess that up across many acres of land? It's sequestering a bunch of carbon. What creosote bush is doing with it, I have no idea. It could be pumping it. Of course, you know, we have great studies from folks like Bob Gibbons on the Jornada. Some time ago, they dug trenches down, and the roots of these shrubs, they're going deep and broad underground. So there's probably a lot of fine roots where that carbon is being pumped underground. Creosote bush does a really good job of doing that. Mesquite also probably does a really good job. We have a number of other additional eddy covariance towers on the Jornada that we're going to be looking at over time. So, and the third way that rangeland health concepts can go wrong is in the way we talk about these systems and devaluing drylands and rangelands generally by this drumbeat of negative press about the degradation of drylands that leads ultimately to widespread public disengagement and apathy. I think this is perhaps the most important problem that all of us that care about these systems face. The definition that you can see in Merriam-Webster for wasteland is barren or uncultivated land or a desert wasteland. It actually has desert as part of the definition of a wasteland. This is a word cloud in a great book, The End of Desertification. That's by Roy Binky. And this is a word cloud of all the press in about pastoralists in Kenya. And you can sort of see cattle rustling, drought is the big one, poverty, conflict. That's what we talk about when we talk about rangelands, and that's what the public sees. Research is really lagging quite behind in rangelands and non-forested systems compared to savannas, grasslands, shrublands, desert, and tundra. We have 3 times as much scientific effort being dedicated to those systems as we do. This is part of a Ignite talk, so it's all on now. Automatic. I got to talk about 30 seconds. Compared to the non-forested lands. These limited research efforts lead to a lack of appreciation. Drylands, and this is important for a couple of reasons. And one of them is that drylands are being increasingly connected to alternative economic opportunities. We often think about drylands, many drylands or rangelands, or wildlands. But distant actors, as you can see in this graph, are exerting ever greater influence over local dryland systems through, for example, the virtual water trade. A virtual water trade is basically agriculture that is conducted in a system where the product uses a lot of water, and then the products are exported to another country in the form of grain. And there's like examples of Middle Eastern countries that are essentially setting up farms in, for example, many places in Latin America, sometimes in conjunction with local companies, but all of those products are intended for export out of the country to somewhere in the Middle East, for example. And you can see the intensity of these kinds of virtual water, virtual resource transfers is increasing dramatically with globalization. And this has a number of effects. Rangelands are being converted to alternative land uses because there's all this additional capital for land conversion, for drilling wells, sometimes in conjunction with climate change, sometimes in conjunction with technologies such as the use of herbicides, no-till agriculture, and that kind of thing. But what we see is massive conversion that is ongoing everywhere in the world, from kind of extensive rangelands, mostly wild, low intensity grazing, usually across many square kilometers, to intensified pasture or cropland systems. And we're also going to see, under the Inflation Reduction Act, it'd be really interesting to see how this plays out locally for us. There's going to be a lot of energy development occurring in rangelands that we're going to have to be watchful about. And another example that kind of hits close to home for me, that little star is the Puesto that I showed in the earlier slide, where I did my work 30 years ago. That is 1972. This is in 2009, and it looks a lot worse if you go to Google Earth. Most of what we were trying to do was, how do you sustainably manage this Chaco forest? And we created a narrative initially. Well, there's a lot of degradation, but maybe we could have these, the Puestos, if they're, the grazing is managed, and we have areas of restoration, we can enhance landscape level biodiversity. Doesn't matter anymore, because this landscape is mostly gone. It's mostly soy. It's mostly buffalo grass, intensified pastures. So how do we put land health concepts on the right track? Make them perhaps work for us, make better decisions. Don't have all the answers here, but this is what the Jornada and many of our partners are working on. The first is location-specific assessment technologies to try to understand what land potential is, to try to be able to track how things are changing in real time. And my titles here are a bit jiggered, but you can still read them. One is a web database and maps of land potential and states to provide site-specific detail on historical vegetation, possible ecosystem states that vegetation can turn to, as well as the causes of those transitions. So we have a database that we work with NRCS on called Ecosystem Dynamics Interpretive Tool, or EDIT, at edit.jornada.nmsu.edu, still in development. But the idea is to be able to take climate regions, you subdivide those into what are called ecological sites based upon a soil map. Each of those is associated with a state and transition model that defines what is the reference condition and some of the dynamics that can occur naturally, the historical range variation, as well as alternative states. And then you can map those. We've mapped, this is the Jornada experimental range with a map of those ecological sites. The major differences in colors are the ecological sites. The shades are the different states of those ecological sites. And this is a powerful, detailed way of assessing land potential, the primary colors. We have different objectives for those primary colors. And then we have different starting points for our management in the different shades, those different states. Each state site combination calls for different kinds of management approaches, and there's different objectives associated with that. And that is the way that the BLM is also managing land. We're still trying to accumulate these concepts and information, as well as NRCS in distributing funds for conservation practices. What conservation practice are we going to apply on this area of land based upon its ecological site, based on its current state? There's certain things we're going to do, and there's certain things we're not going to do in order to attain land health. The next is to try to make access to that kind of information easier. And the Land Potential Knowledge System is a mobile app that allows you not only to identify land potential of the soil, it will help you work with your phone on a particular area. It will help you to work through what kind of soil you have. It can be used to help decide whether it's good for cropping or not if you're outside of the United States. It can get you to your ecological site, and it can help you with monitoring all in one package. And so this is, go to landpotential.org. You can download this app for free on your cell phone. And this is being used globally. It was actually developed primarily for use in Africa, and we're now rewiring this for domestic use. The second idea that we're working with is what I call multi-factor indicator systems, and just to put it simply here, rather than really trying to characterize areas as being healthy or degraded, let's look at a distribution of different indicators associated with each of these states and make our decisions not based upon a single indicator, not based upon this is a good state or a bad state, but begin to think about the distribution across a number of indicators and maybe be able to say, we're going to leave this state alone here because it has this function. Here we're going to, maybe this is a historical relic and we're going to leave that alone. And then here, maybe we're going to try some manipulations and we're going to try to create a complete set of ecosystem services at the landscape scale. And we're going to do that kind of piece by piece, looking at these indicator sets. And so these spider diagrams, we think a lot about these spider diagrams. Some people hate these spider diagrams, but they're very helpful for us to be able to sort of simultaneously see a number of indicators of these different systems. And everybody, each of these has their relative advantage. I think that's probably the most important takeaway here. And then third, community-based management and science co-production, and really being able to take these location-specific assessment technologies, a multi-indicator perspective, and plug that in to different forms of community-based management and adaptive management over time, where we're using monitoring to see what we're doing and adjust on the fly with communities that are often required in these extensive rangelands. There's always multiple stakeholders, including all of you, that have interests in drylands and rangelands. This is an example we've been working for the last 15 years in Mongolia with a project by Green Gold. This was an NGO that is now the National Federation of Pasture User Groups that was funded by the Swiss government for about 15 years. And one of their products was creating a way to organize Mongolian herders to be similar to how they organized their pastoral societies prior to Soviet influence, put it that way. It's pretty politically charged talking about the Soviets right now, I know. So what they did is organize pasture user groups around commonly used communal pastures, and then they created what was called a rangeland use agreement. These are contracts that define the rights and responsibilities of the herders as well as the local government, the equivalent of the Bureau of Land Management here, that had mutual agreements on the definition of rangeland health, and then they communally enforce rangeland health standards with one another. But it also creates an additional benefit. It recognizes land tenure. So you have maybe some restrictions based upon these rangeland use agreements, but there's not formalized land tenure. You own your cattle, but the state owns the land. This allows them to be able to control the fate of the land. And that's particularly important now because there's lots of pressure to convert that land again to cropland as well as energy production. So being able to have land tenure and control that pattern of conversion is a big benefit to these herding communities. And they want to improve rangeland health. So there are 1,500 groups across Mongolia now that have bought into this way of doing things. Then we have, within that context, development of participatory models, state transition models that lead to site-specific predictions. There are management actions that are communally decided upon, and then there's monitoring that then feeds back, and there is an adaptive management cycle where they keep reevaluating their predictions based upon monitoring data, and that's been going on now for about 10 years. And we're sort of at that point now where we can begin to go through these cycles of learning, right? So this is a really important concept, I think. Triple loop learning. And you have your goals, your model, the actions, the management actions you're going to take, the results, and then there's sort of the interpretation and analysis of what you did. Single loop learning is, are we doing what we do right? Right? Are we killing the shrubs? Are we getting a little bit of grass back? Are we doing what we wanted to accomplish given the context at the beginning? The second kind of round, after you've done this a couple of times, is, are we doing the right things? Is this really doing what we want to, want to accomplish with killing shrubs? And then there's this third loop, which is, how do we decide what is actually the right thing to do? We've watched this happen a couple of times. We've thought about the results, and we're beginning to see the options play out. Maybe we're thinking about climate change, and maybe we need to reevaluate just how we're even thinking about the management actions after we've been watching our monitoring data and feeding back to our decision-making process a number of times. And so I think about this, at least in the context of restoration, are the creosote shrublands, are they systems that maybe we want to think about keeping for various reasons? Are there enough failures to get grass back that we're going to choose to, maybe leave some of those creosote bush systems alone? And this is one I had to deal with on the Jornada, and that is this crazy little grass. And then it looked pretty and full, and we have a lot of bare ground, so I'm always happy when I see grass. But that's lemon love grass. That's an invasive grass from South Africa, and it has really picked up the last couple of years. It was kind of hanging in the wings there, little patches. Was introduced, of course, in the 1940s. Didn't really very restricted, but we're kind of entering into a new era of perhaps warmer temperatures, and we're getting some nice heavy rainfalls associated with warmer temperatures, and that grass is predicted to do pretty well. If it's going into a mesquite shrubland that's got mostly bare ground, do I let it go? Do I try to herbicide it, get back to bare ground? Nothing else is going to come to fill that space. It's better than nothing. Better than nothing? Yeah, that's kind of where I'm playing it. But what if it starts to invade the black grama grasslands next door? What do I do about that? But anyway, there's some value judgments there that we're all going to have to deal with. How do we decide what is the right thing? And then finally, positive narratives that connect more people to drylands. One way to do that is rangeland product traceability systems. We're back now to Mongolia. They are doing this really quite well, where you go to, I think Gobi is the cashmere, and of course they have lots of other wool that they work with, camel and yak wool. Yak down is great. It'll keep you very warm. I got very little use for it here in New Mexico. I do have some of it, and there's a little QR code and an app, and that will lead you back to certifications for animal health as well as the rangeland health of the pasture user group, of the area under control of the pasture user group where that wool came from. And it actually connects back to the monitoring data. The standardized line point intercept monitoring data is the basis for the interpretation of the state that is reported as part of the product. And so monitoring data is actually creating value, interestingly, because it's giving an opportunity for customers to pay for land health in the price premiums for some of these products. And that's an idea we probably have to take more seriously here in the US. I know there's a lot of talk about it. And then, of course, the other is to invest in early positive experiences with Dryland. And many of you probably know the Assumbro Institute for Science and Education, which is pretty near and dear to my home and heart. But this is a great example of what it can accomplish. Thank you for the field trip report. I was scared to be in the desert. And now I might become a desert. So we really need to be thinking about those positive narratives, articulate positive visions for the future, where we do have to acknowledge the inevitability of change, that we can't all get what we want everywhere. But we can reconcile multiple ecosystem services at the landscape level, and thinking not about particular sites. I mean, of course, we have to think about particular sites when they're rare and when they're special to us. But we also have to be thinking about this in the bigger picture. And it's a struggle, I think, for everybody to do that. We want everything to be the way we want it. And we have to acknowledge that there's going to be places where there's going to be renewable energy development. There's going to be places where there's ranches. And there's going to be places, of course, where there are wildlife. Thinking about the balance of those different uses. So, to summarize, maybe we can make drylands be examples of wonderlands instead of wastelands, with site-specific and multi-factor knowledge of the land, technologies to access knowledge, local and extended consumer communities. So not only the local communities, but the people who are paying for products that can act on that knowledge, and then really enhancing positive influence about drylands. So thank you.